Welcome to a new test and teardown video. This time it's another military equipment. This is from Danish Military and it's called Intensitetsmåler. So that is intensity measurement model 1965. So, I don't know if this one is really from 1965, the original design, but it could very well be. It is designed for gamma radiation and can also detect beta radiation. We got 4 different sensitivity ranges, and we can zero it, and we can battery check, and this is a disconnect. So this is power off, right? So there's of course a battery inside, and there is a really cool connection from this switch to the meter. See, when I'm turning the meter here, okay, between the different ranges, have a look what happens inside the meter. So that is zeroing, battery control, and to turn it off. It is not perfectly aligned here. It seems like there's a wire that is actually a little bit too short. I would expect them to go a little bit too long. It says also here, I think this is another kind of a order number total 6115D. That is of course the number. But here it says 1966. Isn't that a little bit confusing? And here it's 1965, so belysning, that means light. So there's a bulb behind this meter, right? It's actually open, so we can have a little. Oh, hang on a second. I don't want to drop this. So the way that this works is there is a closed chamber here. There isn't any high pressure or low pressure or anything like that in here. It's just completely sealed. And then we got some electrodes in here. So this is called a ion chamber. And when radiation particles go through here, they will create a charge that is detectable. Of course, it is very, very little charge, and it is also insanely high impedance, the pickup circuit, and this is why they're detecting this using a tiny little tube. Let me see if I can show you the little tube. Where the heck is that? Yeah, here we go. So this is a DF703. Super beautiful. Low voltage, low current. Very high input impedance in its grid. So it can amplify very weak signals. And then we of course also got, look here, AC128 germanium transistor as well. And I think we got, yes, in here we can see another transistor. And the glass parts you see in here, that's actually resistors. Very high value resistors. And you select different resistors from this switch to create the different ranges. I don't have the schematic or the manual. The only thing I could find is a really bad quality, funky angled photocopy on a few web pages. I can just put it in here so you can have a little look. It also says something about this gamma radiation and the beta radiation and stuff like that. But not a lot more is really said. I was hoping to be able to get a lot more from that manual. There's a connector here at the bottom left corner. It is a DIN type of connector. I think this is for an external detector. And then you can use the same meter here and the same ranges and the battery and power and all that kind of stuff. But then you just use an external sensor. So that is just a blank. Inside this case, the case is a bakelite case. And then we find a battery holder. Let's see if we can figure out, is this a single cell sub D or something like that? That'll be the screws. All those screws, they are from the bottom. They go through this case and then they go into the holes here in the front, in the top front. So yeah, let's just take the unit out. Beautiful bakelite case. Oh, there's a little crack here. Oh, that is sad. So this unit was definitely dropped. Oh no. But let's try and open the battery holder. What else do we find here? Ah, yes, okay. This is actually the original band. You stick it. Ooh, I have to be careful this is not falling. So you stick it through here. This way you can lock this case, this carrying case here. There's actually a fun detail about this case as well. To make this watertight, there's actually a piece of plastic in here with some foam inside this plastic rubber thing. But this foam is long gone, super cracked. But this is to make it a little bit nice and soft. So when you're carrying this around and jumping down in the mud and all that kind of stuff, you don't break the meter or the knobs and stuff like that. Real military style. And this will be a hole here in the bottom for the sensor. See here we got sensor input. So you see here, this case here is actually open when you, yes, exactly what you can do. You do it like this, and then the bottom part is open, and then you point it towards something you think is containing radiation or is dangerous. Is this is actually heavy. There's a piece of metal here. And this is also a good test. You close this and then the sensor becomes quiet. You open this and point it towards something and then, or you get a lower reading of, obviously. This is not a Geiger counter, so it's not quiet. It's just me. I'm used to working with Geiger counters, so I'm totally infected by that kind of method, so I'm sorry about that. So yeah, that was a really good quality battery compartment with O-rings and really nice springy connection here. So this is probably minus. Oh, look at that. It is made so if you try to mount the battery wrong, you see, you're not going to get a connection. How nice. There's a little bit corroded in here, but not a lot. That's okay. So let's see. Yes. So the blue one is minus, right? So this is a 1.5 volts single cell battery. So I connected 1.4 volts. I prefer to go a little bit down in voltage because a 1.5 volt battery will drop a little bit. My power supply will of course not drop, so here's 1.4. So we go into battery test. So that should be perfectly fine, right? So that is the 0. So I believe the idea is you take this knob and then you dial for 0. Okay. Here's my 0. And then we go to the different ranges. And we see nothing. Okay, let's try and dial up this a little bit, so at least this needle is not below 0. So of course this is for gamma and beta. It's not designed for alpha. The only source I got is one of those tiny alpha sources from a smoke alarm, and they're really weak alpha as well. So let's just try and put it directly underneath the sensor. As you remember, the sensor hole here is in the bottom of this unit, right? So try to put it directly. I don't know if we're seeing anything, or if is it just because I'm touching the unit actually. Maybe there is. But it is so little, I can't really say. Yeah, okay, see? When I move it on the side of the sensor here, on the side of the ion chamber, I actually do see some sort of reaction. Just to prove it's not me who is absolutely crazy, I got a Geiger counter here, and I will power that up. That is impossible. Here we go. So here you hear some click. This is the background radiation. Now I take my tiny little alpha source. Okay, I should of course remove the maybe it's also here. Oh, that is actually more powerful, isn't it? It's the same on both sides. So there's a tiny little particle down here. It's so little you can't even see it. See what I found in the box. This means tested. 240369 by Ib Jensen. Pretty cool. And yeah, I wanted to show you. This is the wire. So by pulling this wire, this goes down and around the switch. So when I see, and this moves the indications up and down inside the meter. Could have been cool if there was like an easy way to fine adjust how tight the wire is. There is just a screw here, but this seems to be just a holder for the wire, right? It's quite tight. There must be a spring somewhere. So now I took this unit apart because I wanted to figure out what is wrong with this lamp. And the lamp was sitting here, and the lamp was about here, right? But it fell apart when I kind of just touched it actually. So this lamp holder is completely defective. Or maybe the bulb is actually alright. Now it's easier to see the different transistors, and the tube is on the other side. I'm a little bit worried about those cracks. There's also a big crack here and a big crack here. So this could potentially disconnect some signals Now it's actually easier to see what is going on here. Look at the rear side of this contact, or this, it's just fully sealed, and that is the string for the the meter indications. And there's actually also written here 66. So yes, this unit is from 1966. See, if I pull this, you can hear this meter goes up and down. But what I really would have loved is to see this screw being asymmetric or conical or something like that, so you could dial this to tighten or loosen this wire. That could have been such a smart way to solve that, right? To fine adjust the placement. And look, we got a slot here in each of the knob shafts, and that they made with those two, so it's definitely made for super easy disassemble service. They also made quite a few holes for different transistors. And that one was ECO 1103, and that's another germanium diode. And here's my little fix of the bulb. That should be fine. Now I can bend it where I want it, because the bulb was perfectly fine. I don't know if you are able to hear this on this microphone here. But now I'll put the camera down here, and then we'll try and listen to what's going on here, and then I will turn on and off the voltage, and then you will hear if you can hear this, okay? So like this, and then I do on off, okay? So what I hear is, I think there is a switch mode converter here, because there was a big inductor with a lot of connections to it and a few transistors and a diode and stuff. And I think there's actually a step up switch mode converter or something like that in here, and I can hear that is doing its thing. Also, I got this bulb up and running. Let me see if I can show you this. There is not a lot of light in the meter. I'm pushing the, oh yeah, you can actually see it. But of course, let's pretend it is so dark you can't read the meter with the light you have in the room, right? And then imagine pushing this button, and then you get this kind of light. Maybe this will save your day, save your life, save the future of the planet. I don't know. Maybe. So this is the battery consumption, only 23 milliamps. So that is not a lot. So here's a little test using a gamma source. So let's do battery, yes. 0 is okay. Let's put it in the middle. Nothing. Let's go down in sensitivity. I really don't see anything at all with this gamma source. So I don't know if you can hear the Geiger counter in the background. We just performed some tests, and yes, definitely the gamma source is working. So I'm sorry to confirm, this intensity meter is not working.